So in this video, it'll be quite a short one, and we're going to look at the acylation of amines, and this will involve the formation of turning amines into amides. Now, amides are very similar functional group to amines, so you need to be very careful not to mix them up. Amines, if I just remind you, are NH2. Amides have a functional group of RCOO NH2. So when we have now got this group in amides that we don't have any amines. They only differ by one letter in the name, so that's why lots of people get them mixed up. Okay, so please be careful that you differentiate between amines and amide. Okay, so there's a couple of reasons why we need to know about this reaction. First of all, we need to know it in order to show us how we would actually make particular amides. And secondly, we need to know it because it is a reaction which is used to identify unknown amines. Okay, in the similar way that we used, if you can remember, 2,4-DMP to recognize or to identify, aldehydes and ketones through the formation of the solid derivative, and then recrystallizing that and finding the melting point. We'll do exactly the same here with this, but we'll get to that in a second. Okay, so if we take an amine with an acylating agent, okay, an acylating agent we'll see down here is acyl chloride. So for example, so let's take our amine, whatever it happens to be, with our acylating agent or acyl chloride, we get what's called an N-substituted amide. Now that's a whole new functional group for you. Okay, so we'll just break it down a little bit. So if I take a normal sort of standard primary amide, it is as so. What we get here then is N-substituted amides. Okay, and you can see an R group, an alkyl group, okay, has been put on here. So we've taken our hydrogen off, and we have an alkyl group has replaced the hydrogen of the original amide. Hence the term N-substitution, because the substitution has taken place on the nitrogen atom, not perhaps on the alkyl group that we have here. So that's why we get an N-substituted amide. Now, your R group that you have here will depend on your original amine. Your R group that you have here will depend on whatever acyl chloride you react with your original amine. So provided you know your acyl chloride, whether it's ethanoid chloride or propanoid chloride, and provided you know your amine here, whether it be ethanamine or propan amine or whatever, you can work out the structure of your new N-substituted amide. Okay, you also get the HCl produced here. Okay, so again, if you're asked to write a balanced symbol equation for this, HCl would of course come into play. So if you could write an equation for the question on the board based on what we had on the previous slide. So maybe I'll just pop back to the previous slide. You could perhaps take a photograph of that and refer to it. Okay. It is, however, pretty much the same as what I have on page 216 of your textbook. Okay, so if you, it's 216 of the textbook there. Okay, so just pause the video and have a go at that. Okay, so remember my R group on my amine is this. So therefore my R group on my N-substituted amide is going to be that. My R group on my acyl chloride is CH3, so again my R group there. And don't forget when you're writing the balanced symbol equation, you've got to put the HCl in. If it asks me just to draw the structure of the compound, the organic compound, then I wouldn't need the HCl. Okay, right, we've got to name this then. So this is, how do we name it? Well, let's look at the amide, the amide, that's the remnants of the amide. That has 2 carbons in it, so it is, and you can see it there, ethanamide. Okay, the substitution has taken place on the nitrogen, so we have M, ethyl. Okay, ethyl is this group here. So if we looked at just at this compound here, that is ethanamide. We have now turned this to a C2H5 here, sorry, C2H5 there. So we have got N, substitution on the N, ethyl, and we originally had ethanamide. Hopefully that makes some sense to you. Now, where do we use this? Well, sorry, observations first of all. It's a very violent reaction, lots of heat, and we get a white solid. So this is our white solid. And if you remember earlier, I talked to you about using the 2,4-DMP derivative of an aldehyde or a ketone to identify that original aldehyde or a ketone through recrystallization, and then finding its melting point, and then backtracking to identify the original aldehyde or the original ketone. But we do the same here, and we use this white solid. Okay, so what we do is we, again, like I said, we recrystallize that white solid, we find its melting point, and we refer to data tables, and that allows us to identify my original amine that we had. So make sure you go to your practical guidance and learn the little practical on how to recrystallize and how to do a melting point analysis. Okay, so there's a question, 5.9L. If you could pause the video and do that, check the answers from your textbook. And another one. Again, pause the video. Okay, so that's that video done, guys, and that should bring you through to the end, or sorry, halfway down page 217. So what I've covered there, a very small part from page 216 to 217. It's page 216. It's the bottom of it, making amides, to 217, about halfway down page 217. Just to the part you'll see in your textbook, it talks about azo compounds. We haven't done that yet. We'll start that next class.